So this is like the final push now with equations. We now have acquired all of the skills that we need. You know generally when to add, when to subtract, how to multiply, when to divide, when to put parentheses and kill fractions and stuff like that. So the first 3 weeks are pretty concentrated on just acquiring that basic knowledge. I wish it didn't take 3 weeks, but it is what it is. It's time well spent because your ability to solve an equation never, it's like it never becomes unimportant as long as you're inside of a school. So time totally well spent. So if you're on a Chromebook, make sure you're not on that Chromebook anymore. Um, Make sure you close those things down. You should have your notebook out with your pen or pencil ready to take some notes. You're fine. So if you were to go back and look at the hundreds and hundreds of problems you and I have done together in the first 3 weeks, not that you would see that not a one of them has had a variable on both sides of the equal sign. That is very much by design. So what the skills I'm trying to get you to acquire first are, again, just the recognition of when to add, when to subtract, when to multiply, when to divide. So at this point now, starting today, this is where we really open it up to like, okay, from this point on, after today, anything is possible. These equations today are all going to be, almost all going to be three-step equations, very repetitive. And there's a lot of examples and there's a lot of problems in the assignment. And the reason for this is because I want that repetition. Here's the deal. As the equations starting, say tomorrow, what's tomorrow? Wednesday, Thursday, get longer and longer, they always come back to looking like this. This is always what a math problem will look like when it's almost done. So we want to master this part of it, like the ending three steps, so that when we do the big fancy ones and we knock them down to looking like this, then we just go, cruise control. Easy peasy, right? All right, so here's the deal. Once you get down to this point, you want to think about like, can I combine any like terms? And the answer is, of course, no. So what we're going to do repetitively is step one, we're going to get the variables onto the same side. So there are two correct answers to this question, and I'm going to do them both. But before you write anything down, don't write this down. There's the yellow option and the red option. Let's talk about each of them. What good thing would the red option accomplish?
Take care of the 4x.
It'll take care of the 4x. And that's really the goal. If you think about it, when you quote unquote move something over an equal sign, all you're ever doing really is killing it on one side so that it can reappear on the other. So minus 4x is not a bad move because it'll get rid of the 4x. Tell me about the yellow. What does he accomplish?
He takes care of the
He takes care of the negative 2x. So I am going to impose upon you an opinion. And you do not have to take this. You do not have to put any weight on it. You can just totally thumb your nose at it. I would pick the yellow almost 10 times out of 10. And I don't know if you heard what Riley said, but Riley's heard this speech before. But I would pick the yellow because when I'm done with the yellow, what kind of number is going to be in front of my X? A positive. And my informal research would indicate that teenagers generally do better at the end of an algebra problem if they divide by a +6 instead of a -6. So you have options. You can either move the 4x to the other side, or you can move the 2x to the right side. You're going to see throughout this lesson today that I almost always pick the one that is going to cause my x to be positive when I'm done. You shouldn't really worry about whether it's on the left or the right now. That'll matter when we get to inequalities, but for equations, it doesn't matter. So now we should start writing again. Let's all add 2x to both sides. So what that does is it eliminates these x's over here, and we bring down the 5 and the equals and the 6x minus 19. This. Any questions about that?
-9.
So step one was to bring the variables to the same side. Step two now is going to be to just do what you're used to. The numbers, bless you, to the other side.
So
We want to add 19 to both sides now. Correct. Like this. And then we're going to bring down the 6x and the equals and the 24. And then we're going to divide both sides by 6. Bless you again. And we're going to be left with x equals 4. I apologize in advance for what's going to feel like a lot of examples, but I want to say again, from my experience, like this has to be good. This has to be like, I don't even hardly have to think about it while I do it kind of good. Like I could almost do it in my sleep. So one down, many to go. Let's go again. And I did write this lesson today so that all of our answers will not be fractions. I'm going to save that for a different day. So everything today in the notes and everything in your assignment should come out to nice integers, as we say, no fractions. You should not even, if I'm any good at this, you should not even be thinking about these. And I have no idea why people do that, but the 11 and the 3 should not be.
Because you can combine like terms, which makes that 4x.
You cannot combine those to make 4x. And this is really
Because the
where the
equal-
trouble starts. The equals is the great blocker. And he basically says you can do whatever you want over there on the left, and you can do whatever you want over there on the right. But if you're going to make the things on the left interact with the things on the right, you got to follow the rules. And the rules say, like, first off, does this x want to be with this 3x?
Yes.
Yes, but he can't just join him and make 4. How do we make the magic happen? You subtract one of them to make it go away. That's how you make things move over equal signs. Is you kill them on one side, they reappear on the other side. So I have options. Should I subtract, bless you, should I subtract the 3x or subtract the 1x?
The 1x.
Subtract the 1x because when I'm done, it'll keep my x positive. I'm going to do the next example on, or one of them at least on purpose to show you that it doesn't matter if you make it positive. It just, you're going to get the same answer. I just like our odds better if we keep our x positives. These are going to go boom, bye-bye, gone, boom. And how many x's do I have left over here?
2.
I had 3. I took away 1. I've got 2, right? And there's no decision to be made now. We got to get rid of that 11. How do we make him go bye-bye? We add because he's a minus. And then we bring down the 2x. And we are never allowed to mess up our 4th grade arithmetic. What's -3 plus 11? +8. And then we divide both sides by 2. And we're done. What's going to wind up happening is I'm going to ask you to start solving equations at some point like this, like 1/2 of 3x minus 4 plus 2/3 of x minus 9 equals 1/4 of x minus 3. And what you're going to find is even though the equations start to look harder, they always in the end, always in the end, always in the end wind up looking like this, which is why we're practicing this today. No matter how complex equations get, they always come back to look like this. Okay. All right, let's do this next one a little bit differently on purpose. So our problem is going to be -x minus 4. I just want you to see that it doesn't matter. In fact, I'm going to draw a curtain here and put the problem on the board twice. Anyone in this room right now feel like you've already got this and you can just ignore me? Because if so, I want you, if you're in that group, to solve the one on the right by doing this step right here. The rest of us are going to go rogue, right? Why would we add x to keep it positive, right? Okay, so the rest of us, let's just prove while these monkeys go and solve it the red way, let's go our own way, the other 22 of us, and let's solve it the kind of maybe less normal way. So instead of adding x to make it positive, let's take this 4x and say, I'm going to get rid of you. I'm going to subtract 4x from both sides. And what I just did is not a crime. But what I did is I put myself in a position where the answer to this purple box is going to be a negative number. No big deal, right? If you're good at negatives, none of this matters. If you're good at basic math, you won't get stumped all year. How many X's do I get from the purple box? Y'all see the purple box? Put negative 1x together with minus 4x. How many x's do you get? You get negative 5x. Whereas the red people over here are working with positive 5x, right? We're kind of side by side here. And then I'm going to bring down the minus 4 equals and the 31. Right? What's the next step?
What do you add for?
You, of course, would add 4. It's now time to put the 4 and the 31 together, and we have to do it by legal means. If they're equal sign jumping, we got to use the big
Would
weapon.
be 35.
So we get negative 5x equals 35. Let's get caught up to the red group over
You
here.
divide both sides by 5x.
Negative 5.
Negative.
So let's get caught up to the red group real quick. The red group, if they actually did this and didn't just nod their heads, then what they're working with right now is negative 4 equals 5x plus 31. So if you're in the red group over there, what is your next step? Rowdy?
Minus 30.
Let's minus, subtract, take away 31 from both sides.
When you should get 7.
And the red group has 5x equaling negative 35. Look at this awesome dynamic that the yellow group over here is dividing both sides by negative 5, which is a positive divided by a negative, which is a negative. Whereas the red group over here is dividing both sides by a positive, but it's a negative divided by a positive, which is still a negative. The moral of the story, and I'll never do that again. We're never solving the same problem twice. I want to make a point that the moral of the story is you can do it however you want. But I play the odds and I think we're going to do better if we keep our X with a positive number.
I got this one. I just forgot the negative.
Nice. How about this one? Which X do we want to move more, the 8 or the 7? You should want to do the 7, especially in a case like this, because if I take away 7x, not only is my x going to be positive, it's going to be a very special positive. What is 8x minus 7x? 1x, also known as x. You really should start to outgrow those training wheels right about today, where you stop putting ones on things where they don't need to be, because a 1 will make you think you're not done, when in reality, we're about to save ourselves a step by not putting the silly 1 where that little arrow is pointing. Because now you see, hey, there's nothing attached to the x. So how many things do I have left to do? Just one job. What is it?
Get rid of the 13.
Get rid of the 12.
The 12.
Get rid of the number that's by your x. Let's subtract 12 from both sides, and we're left with x equals game over. Done. So every once in a while, if you play your cards right, you can combine your x's to just have a regular x when you're done. Okay.
That makes more sense.
I'm glad. How about this one? Who do you want to move, negative x or positive x?
Negative.
You should want to kill that negative x, because the act of killing the negative x will force my x to go positive.
So do we add x to both sides?
Let's do that. Let's add x here and let's add x here.
Would those x's be 2?
Are you talking about these ones?
Yeah. would those be 2?
Absolutely. There's 2 of them. Yes.
Plus 2 ones. Or equals negative.
Next step.
Then you want to get rid of the
The 3 is the bad guy. He's the straggler that's on the same side as our boy X. And so 3 is our target. Algebra problems just they always finish the same. You got to come down to the home stretch and go, I know you, three-step equation. Move the x, move the number, divide like snooze fest, easy, repetitive.
And then you divide both sides by 2.
And then we divide both sides not by 2x,
By
just
2.
by 2. Never divide by the x itself, just the number that's in front.
Which that's equal.
Tienen que decir la respuesta en español, solamente español.
Right?
X igual a
Right?
negativo 9. Right? Let's do another one. I'm going to skip a couple now because I know you've got this. So Ahí, lots of big numbers, but I am not scared.
Wouldn't you get rid of the 25 first?
I would. Again, if I say this a lot, if I'm any good at this job, you already have gotten the memo today that we're going to pick the X's and we're going to pick the one that's smaller. I didn't directly use those words, but I'm sure you've deduced that. Ignore the 92, ignore the 65, control the X's while you have a chance. Because once you start messing with the 92 and 65, you've lost control of the problem. So I'm going to go and say X is over here, I have 28, X over here has 25, 25 smaller, 25, prepare to take a dirt nap. Goodbye. Like this. Right? So my X's go bye-bye over here. And I'm left with 3x.
Oh, I punched the wrong number in and then tried that and it didn't come out good.
I'm sure you're the 12 millionth kid in this great nation to do that already this morning. So it happens. Next step.
And you're gonna kill the 65, right?
65 is not bothering anybody. The equal sign is your divider. He's your decider. The equal
the
sign is
92.
here. It says variables over there. That's the side where we need to protect our boy.
So we'd add 92.
We have to get rid of the 92, right? So we're going to add 92. 65, bothering nobody. And we're left with 3x equals positive something.
27.
27. Divide both sides by, and x is equal to, oh yeah.
It really is.
It will not. Listen, eventually, like I showed you earlier, it's going to blossom. I made the concerted choice yesterday, last night at home, when I was sitting there preparing for today. I'm like a kid in a candy store. My downfall as a teacher has been that I write lessons and I just start going, ooh, we should do this. And oh, well, if we're going to do that, we should do this. And next thing I know, I've bitten off more than maybe we want to chew. Today is going to be pleasant, repetitive, but they're going to blossom eventually into longer, more difficult situations. But as long as these fundamentals are intact, good. Let's do 2 more. I had about 6 more on the note card. Let's knock it out and do just 2. I think that'll be plenty. I really like this one. The reason I've selected this problem is because I have to ask you a fundamental question. I'm going to point to 2 numbers. Those numbers are -1 and -9. Sorry if you missed this, but we're not going to make fun of you. We're just going to correct you.
We're gonna get rid
Which
of
number is smaller, -1 or -9?
-9.
-9 all day long. Remember that just because like 1 feels smaller than 9, with negatives, we have to flip our thinking upside down. So we should be thinking that -9 is the one we want to get rid of because he's smaller. Good. So that was why I wanted to do this problem, was to make sure that when they're both negatives, you understand still which one is smaller. So we're going to add 9x to both sides. How many x's on the left? What do we have over here? 8 x's, you bet. Next step. Yep, 9 is our guy, right? It's there's not even a decision to be made here. -9. And the separation is now complete. Really, algebra is just a matter of can I separate? Can I separate the x's onto one side and the numbers onto the other? It's just like a game. And it's done. The house is clean. We're ready to go in for the kill shot. Divide both sides by 8, and it's over. Divide by 8, divide by 8, x equals. Done. Last one. You guys rocking this? You feel good? Good, good. 4x plus 1001 equals 5x plus 1006. Those might be big numbers, but why don't I need a calculator for them?
Did you get rid of the 4x?
Because when you subtract them one from the other, them being so close together, like you don't need a math degree to know that, like, if you have $1,006 in your bank account and you spend 1,001, you got $5 left, right? So we're not going to be scared by large numbers. Sometimes we might want to type them in, but in a case like this, we're like, nah, I don't need that. Let's talk x's first. Who do we want to kill, 4 or 5?
4.
4, because he's smaller. So let's get rid of the 4. And eventually we will someday not be showing all of these steps, but for now we're going to stay strong and keep doing it. We're going to bring down 1001 equals 1x. So just put x plus 1006. And again, no calculators for a problem like this. Just because they're big doesn't mean they're scary. Which number are we going to subtract?
To 1006.
For sure. Get rid of the one that's over there bugging your dude. What do we know about this answer? Positive or negative?
+5.
Definitely negative, because you got a smaller number being decreased by a bigger number. So the answer is -5. So what? No, you're not going crazy. So your assignment today is on the computer. Again, I will be closing tabs if I see your Chromebook on anything other than Delta Math. So get your Chromebooks out, fire up the old Delta Math. You should see an assignment there. It assigned itself like 10 minutes ago, maybe something like that. It's there. It's like, I don't know, 30 problems, I think. Oh. I will pause the recording. If you get one on your screen that you want some help with, let me know. You're going to find this to be exactly repetition. And I did click through a bunch of the Delta problems because I could just go new problem, like over and over. I spam that button. All I saw was whole numbers. I didn't see any fractions. So if you get one, lucky you, I guess.
Lucky you.